The other one that we tested more recently, a couple of years back, on STS-118, was a drug that is being developed. It's still actually fairly early in its development cycle, but it's targeted against muscle loss. And for anybody that knows this field, knows that there's really very few, very poor options for doctors to prescribe currently in muscle arena. Steroids simply have too many terribly negative side effects, and while they can be useful for certain things, they can't really be useful for chronic issues of muscle loss. There are a number of conditions that would benefit from having a therapeutic, muscular dystrophy being one, of course was mentioned in a different context earlier, is just an absolutely terrible disease, and one that if there's any chance of benefiting would be very valuable to do so. Cachexia from cancer, essentially muscle wasting, is also an area that has great potential because it is thought to be one of the major contributing factors to morbidity in cancer-related deaths. And so if you have a way of keeping up the musculoskeletal system, and muscle in particular, then a person will have a better ability to withstand treatments of cancer and be more likely to survive. And then finally, sarcopenia, which is just the muscle loss that we all suffer and fight against with aging. A lot of people recognize, of course, that for the elderly that get frail, that if you fall and break a hip, that's a very, very bad thing. But in fact, the reason a lot of people fall is because they get weak and they get unable to be able to stand as solidly as we do when we're younger. So anything that can help to improve our fitness would be obviously a good thing. Amgen has tested inhibitors against a novel pathway, another interesting discovery called myostatin. Myostatin is a negative regulator of muscle, which just means that the more of it there, the less muscle you have. So anything that interferes with this pathway promotes muscle growth. And in fact, you can see with the mouse knockout there on the right, that is not a fat mouse. That is a very lean and very muscular mouse where the myostatin gene has been completely knocked out. We tested myostatin inhibition on STS-118 to mitigate tissues, muscle loss, and I'm just going to show you this is my little bit of data that I'll show you here. The graph in the upper left shows the effects of this drug on body mass. So the first thing I'll tell you is we selected the mice that were used in this study so that they were very, very carefully weight matched. That's why they fall on top of each other so nicely. That's by design. And then post-flight, this was about a 12-day mission. What you see there are the ones that don't receive any drug but that are flown will undergo significant body weight loss versus the animals that are kept on the ground but not treated. They undergo, actually, they're still growing. They're just at the end of their adolescence and growing just a little bit more. So they actually put on weight versus the ones that are flown and lose a little mass. The thing that I want to point you to, of course, is the gray curve on top showing that even in a spaceflight environment with this therapeutic, by inhibiting myostatin, we can promote a tremendous amount of muscle growth, actual muscle growth. And if you break that down on the far right there, I've actually broken it down showing just the deltas, the change in mass between pre and post-flight under those three conditions, and looking at changes in body mass, lean mass, and fat mass altogether. And there's just no two ways about it. This is a very profound compound that even in, again, a very strongly negative environment that promotes muscle loss, that we can actually promote muscle growth. And these, of course, are animals that are not exercising in any significant manner. So this has great potential for a number of serious diseases, but also has great potential for being developed as a countermeasure. We're working on that publication and hope to have that out here shortly. In the area of education, we're supporting a series of experiments that we've been doing where we actually put experiments on the space station that have visual imagery associated with them, where those images are sent down and then put into a classroom. to students that are participating in that. The most recent one that we did here, we flew a couple of different species of butterflies in space and looked at essentially the whole life cycle of the organism. I had a little video associated with this. I won't show you as it wasn't actually working, but if I could have shown it, I would have shown you a composite that fast-forwarded through the whole development cycle, showing the growth of the larva, the successful ability to pupate, and the formation of adults coming out of that. What was really exciting about this was we really had, of course, no idea. The idea was to put science in the classroom, and we didn't know what the outcome would be, so that students, even in the middle and high school level, could participate in science where they didn't know what the outcome would be. They could form their own hypotheses, their own theories about how it would go, what would happen. I'm happy to report that they were able to successfully form to adults. And what was most gratifying to us is that we had 180,000, conservatively, 180,000 students, middle and high school students, participating directly in this research and following this research as it was playing out on the space station. We're planning to continue this type of research. We have plans for the next 2 and hopefully 3 shuttle missions. We are looking to transition into a post-shuttle era. It was discussed earlier, the idea of developing instrumentation. We're looking at different ways of taking the hardware that we have to date and utilizing that with instrumentation on the space station, and better utilizing even the assets that are there, such as the glove box, low temperature storage systems, etc. And are doing planning now with some of the other vehicles that we expect to be able to carry our research up and down opposed to the shuttle. And I just want to end by saying I think that the space station, to me, is a very exciting, it's an incredible facility, clearly. And the one thing I guess I will point out from my own sort of editorial perspective is that if any of you have not had a chance to go see the Hubble Space Telescope IMAX that's at the Visitor Center here, I strongly recommend that you do that. But what I want to point out in terms of making a comparison here is I don't think anybody would have a hard time arguing that the Hubble Space Telescope isn't a worthwhile instrument, that it doesn't advance our knowledge in ways that enrich us as a species and as a society. But there's no chance that a killer app is going to come from the Hubble Space Telescope. There's no chance that something that's millions of light years away is going to affect our lives right here. On the other hand, this is a facility that does have that opportunity, and frankly, even if no killer apps come from it, I think the body of knowledge that has already been garnered from spaceflight research and that I think is going to come over the next 10 years is going to be tremendous and will enrich us in ways, not just in terms of how it affects our lives, but just in the body of knowledge that